All right. We are Team 10. I'm Alex. This is Sam. This is Andrew. This is Minesh. We are going to show you today our candy firing pirate ship. So one of the first things that we attempted to do and were able to do is actually build the hull of the ship. Originally we were going to sort of build a square and then use a lot of extrudes to sort of take sides out of it. The problem was we struggled if we wanted to have both a curvature along this way and also a curvature along this way. We were struggling on how to do that. Eventually, once we were able to learn how to use surfaces and boundary blends and then thicken that, we eventually were able to do that. So what we did is we modeled one side as a half of the ship. In this case, we modeled the right side first and then had a mirror part of the left side. And as we continued to add features, the two sides were still linked, so it could continue to update. So we just started with the basic hull of the ship with no windows. And we had the backside, and then we did some boundary blends. The problem is, when we eventually got up to the front, the boundary blends didn't really want to merge. There's too tight of curves here, so we did a lot of sort of experimentation on how to actually get the part to work. So we had to continue to make these datum curves here a little bit wider, and eventually we got one that worked, and we just sort of left it. Unfortunately, it left us sort of a very stout ship, but we left this before we knew what exactly mechanical parts we would need on the inside for the mechanical mechanism. So although it's tall, it does fit everything, and it allowed this surface to work. So once we had that, we continued to add features to make it look more complex on the outside. Also allow you a bit of a view on the inside so you can sort of see what's going on with the mechanism. We added port windows here. We had a big square window for the cannon. On the back, we wanted to do a window but make it a little different, so we have this grating here. So all we did is extrude holes in, and then we extruded the frame out. Now we are going to go to the inside of the ship to explain a little bit more on how things work.
Sure. So the outside of the ship, pretty proud of, but the inside I think is where we spent a lot of time, just because it is bigger, it is a little bit stout, as Alex said, but there's a lot of stuff packed in here, and we did a lot of design work into making sure everything fit and to making sure that, well, I guess as you can see here, the all the candy is held in the up in this physical model in the mast here. We loaded in the crow's nest, and it all stacks up. And then, as you can see here in the model, this piece here actually moves. How do you move it? And there we go. No, are you sure? Yep, yeah, sure. So this piece actually moves back and forth, metering in one piece of candy at a time. And so we had a lot of just design issues on how we were actually going to make this work, and it's actually all controlled by just the child pushing the toy makes that go back and forth. So potentially the faster they push it, the faster the candy gets metered in there. And then let's see, some other interesting parts that we have on here are this motor and this throwing disc. So this is a DC motor attached to a AAA battery, and this is actually a wheel that's on the inside, and it spins, so when the candy falls in there, the wheel pushes it out and it shoots out the cannon. So there's a lot of working mechanisms that are going on inside of this ship. They're all kind of enclosed in this area, so we had to make it a little bit taller so all these pieces could fit. So then, do you want to run the actual? Yeah, there we go.
So as you can see here, we left a datum curve on the wheel so you can actually see it spinning. So as this runs, the hopper moves as the child pushes the toy along the floor. So this wheel will actually move, and then there's a rubber band connecting this sprocket to this sprocket. That moves the meter back and forth as the candy comes in one at a time, and then this wheel is constantly running as the on-off switch is switched on or off. And so the candy will come in, fall into the cannon, the wheel spins, makes contact with a piece of candy, rolls it along the wall, and we'll shoot it out the cannon.
No, I'll talk a little bit about the actual physical model. As we were building this, ran into numerous issues, as you can probably guess by how tall it was. And we were worried about volume restrictions. We couldn't make it wide enough to really balance the part well, so it's very uneven. So that's why we have this leg piece right here that just keeps it from falling over, basically. We also ran into a few problems with tolerances. We did tolerance things, but we didn't give big enough clearance, which led to issues having to sand, file away parts. Overall, we got everything to work. One problem we do have is it will sometimes jam when there's. We had to change what candy we're going to use because of clearance problems. So sometimes we'll jam if you have numerous pieces of candy in the actual hopper. But if you use one, it should work pretty well. So I guess here it goes. And the motor is pretty loud, as you can tell, which is a problem. And but I think our battery's getting ready to die. Yep. There you go. So, yeah. So that's our toy. I guess. So,